the webinar, the agenda, introduction, then live demo of your top 10 tips and tricks, and then at the end of the webinar we'll do a quick summary where you can find the video to download, as well as I may be able to answer some of the questions that you've put into your into the question box. Right, before we go ahead, quick introduction to A2K Technologies. Most of you will be aware of who we are. However, we are a solutions, training, consulting, and management firm specializing in design technology. Right, so we've got over 150 staff, and with that, we are Australasia's largest Autodesk channel partner. We are servicing infrastructure, building, mining, construction, and manufacturing sectors. So most of you are probably from the building sector. However, we are servicing other sectors as well. Most of you are aware that A2K is selling Autodesk software and that we are providing training and support for AutoCAD, Revit, etc. Right? However, beyond this, we are also providing hardware services. So, for example, we are HP partner, as well as a variety of other software and services. We are Microsoft partner, Adobe partner. Other services we provide is IT services. We've got a great support team and so forth. Yeah, all this is really making, or should be making us your one-stop shop for all your office IT needs. Just a quick overview about the technical team. So I just mentioned we've got 150 staff. Lots of them are lots of them are technical experts. So we've got 35 technical experts in our team. Yeah, we've got lots of different skill sets and lots of different technology products that we cover within our team. Right? We do, or most of our technical staff is coming from the industry. So most of us had, you might say, a real job before what we're doing now, and yeah, we're fairly well experienced. So our average industry experience is 15 years. We've got staff and offices all over the place in Australia and New Zealand. Yeah, some offices are a bit larger, some are smaller. Yeah, we're scattered all over the place. Quick introduction about me. So my name again is Klaus Strohel. Say that name 3 times quickly, and you're very good. My role here is I'm a technical consultant, and I'm in the Hobart office. Right, so Tasmania. I live in Tasmania because it's very nice in January, and my qualifications or my background is in civil engineering, focused on structural engineering. So I've got industry experience in structural engineering and yeah, mainly Revit implementations in consultancies in Germany, but also nowadays in Australia. I'm with A2K since 2013. Also, I'm in Australia since then, so for roughly 2 years now. My main role here at A2K is Revit trainings and implementations, but I also do a lot for design content and BIM mapos and create Revit families and help developing them. Right, that's the list of tips and tricks I want to go through with you. So I've got 10 altogether. First of all, create positive and negative offsets. Second is arrays, how to chaos prevent them. Third and fourth is related to arrays as well. One very interesting one I find is a one-member array, because that's yeah, out of the box not possible. There's a very good workaround for that. Number 5 is going to be position and orient MEP connectors anywhere in a family. This technique can be used for other families, not only MEP content. It's fairly complex, but yeah, very good workaround as well. Then 6 is save in-place families and system families as component families. Whenever you've created an in-place family before, put some effort and time into that and then want to save it in your content library. That that's not possible out of the box, but there's a good workaround for that as well. Number 7, that's probably very interesting for architects, painting surfaces via parameters. However, on the structural side, so my background's mainly structural, we can use that as well quite a lot. So have a look at that. Number 8, the power of 2.5D families, 2.5D families. What is that? Yeah, it's the best out of 2 worlds. Keep it very simple, but still functional and looking at the elements that we're placing in a variety of views. Point number 9 is make a ceiling-based family face-based. So you may have had a light fitting, for example, before that you were only able to place in the ceiling, and yeah, whenever you don't have a ceiling provided from the architect via link file or so, you were kind of stuck and you had to create a ceiling to place that family. There's a good workaround to make that actually face-based, right? That's an undocumented one, very good one. Number 10, just a couple of hints for family organization, how to set up thumbnail views, and also yeah, to create a default type when using type catalogs, because it can become very messy otherwise. Alright, so let's start with the first tip and trick. Positive and negative offsets, right? So just what you see here, that's a sample framing family, so structural framing family. The example I'm creating now is not a structural one, so it's a generic one, but prior to 2014 we always had our steel framing members. When you opened the families, they looked so complicated with all those parameters that are only allowing us to create a start extension which is positive as well as a negative one, right? So, and how that is working, I'm going to show you now in my Revit environment here. So again, you see that framing family here, we've got an end extension which can be positive and an end extension that can be negative as well, right? So this can be used, for example, for offsets for duct outlets. So I've created a duct outlet here which I can place into, so an air terminal, sorry, that I can place on a duct, right? So it's going to place on a duct, but if I want to move that up or down, I usually have an offset parameter here, but if I try to do that, the family is going to explode. Therefore, I created an offset parameter manually, which I then can control where the geometry is. However, the connector is still in place and it's still all connected well. So another point where this technique can be used, or where I actually use it most of the time, is on face-based families, for example, air grills or nuts and bolts on the structural side. So when I place these elements, again, I create similar, place it on that face here. I think, oh, I need to have an offset of 50 mils because I need to lift it up a little bit. But face-based families by default don't have an offset parameter here. Therefore, I need to implement that offset. And if I want to have that element sinking into the element that I place it on that face, I need to be able to make a parameter that can go up and down at the same time. So I just start a new family here. So family, I use a generic model face-based template. Say open. So while I'm creating this first family, I'll give you a few little tips and tricks on the side how to best set up a family. So to set it up best, usually create reference plane, right? Create scaffolding of reference plane, and then once they're all in, create parameters or create dimensions, turn them into parameters, and see whether they're all moving parametric the way you like. And last but not least, you create the geometry and lock your geometry to those reference planes. So this is always going to be the way you should create your families, whether it's MEP structural or architectural ones. Okay, so those dimensions here, I'll turn them into labeled parameters. So this is Y. Make it an instance parameter. This one here is X. instance parameter as well. I won't go into details like what the difference is between instance and type parameters. That's something I think you, if you are interested in that webinar, you should know already. If not, would be a good time for you to do some background research. Alright, so I've created my scaffolding and now I'll start to place in my geometry. However, because I want to have this offset set up, I'll go into my front view here. And when I create my geometry now, it's locked, or it's based on this reference plane, right? And when I then place it into my project, I can't offset my geometry. Therefore, I create a reference plane a bit further up to start with. I could create it further down, but that's the way I'm going to show it. With all those families, you've got a lot of elements on top of each other. So when I place a dimension in here, like now, I got to make sure that I pick the elements I'm after. So I'm after that reference plane that is aligned with that reference level. So put that here. I name this offset for now. Right? Offset. I'll make it an instance parameter as well. Say okay. So I name this reference plane. It's always a good thing to do. Name your reference planes, otherwise you get confused which reference plane is for what purpose. And another reason for that is, I'll show you shortly, base plane, for example. Now when I go back into my floor plan here, I'm now able to, when I say create, set the work plane to that base plane here. Say okay. And I now create my extrusion that I'm going to lock to those reference plane that I've created. Create a rectangle. If you only see your reference planes, you can draw them straight on here and then lock them to your reference planes, like so. Finish that. Because we've created that extrusion, on that base plane, reference plane, my extrusion is going to be locked to that, right? Another reference plane we'll put in is a reference plane to control the thickness of this one here, right? So I always recommend you to use the align command, so this one and that one, lock it, put in another dimension, and name that thickness. Call it, make it an instance parameter as well. All right. So just to quickly show you what we've done, I just saved this family into. Oops. Sorry, creating positive and negative offset. This is our offset family 01. I load this family into my project and I'll place it on a face like so. With this offset now in my properties, I can move it up, right? So I can move it up by 500, can make it flush, but I can't type in a negative parameter, right? So it's going to explode, because Revit does not allow for length parameter that are assigned to geometries to be negative. Therefore, we got to do a workaround for that. So the workaround is the following: I create another reference plane a bit further up. Then I dimension that reference plane again from this one down here. I'll then dimension the top one down to this one. So I remove that offset parameter out of my view here so that this one is not directly controlled by the offset parameter, but it is going to be controlled by those two help parameters that I'm setting up. So I change that to be a label and call it offset help 1. It's got to be an instance parameter as well now. And I call this one offset parameter 2. Offset help 2. Make it an instance parameter. Right. Now what we need to calculate is that when I type the offset in, so in my family type dialog, I can still see my offset parameter. So this should be the offset parameter. That my offset help 2 is going to be offset help 1, which is going to be a fixed one, minus the offset. Therefore, I said offset help 1, I make that a fixed parameter like 1000, and then offset help 2 is equals offset help 1 minus offset. Therefore, when I type in offset of 200, my offset help 2 should become 800. When I apply, I can see that's working. Now when I type in a negative offset value, like minus 200, the offset help 2 should change to 1200, which it does, and therefore giving me the option to type in a negative offset value. Right? Apply and OK. I load this into my project again, overwrite the existing version with its parameter values, therefore I can select my family. At the moment it's got 500 offset, make it negative 500, and I can offset it negative off the surface of that insertion plane, right? So, and that's basically it. So you can foolproof it now as well. So at the moment we can only give it a maximum offset of 1000 because it can't be more than this offset help 1. So if we give that a very high value, like I don't know 20,000 or something like that, I should never be able to reach that because I will never have an offset high like that. I will provide you with some of the sample files. There are a couple of formulas embedded here which allow you to foolproof this family, right? But I won't go into that because we don't have enough time, unfortunately. So yeah, that was the first trick I wanted to show you. And let's go to the next one. Arrays, chaos prevention. All right, chaos prevention by nesting families. Everyone who has created arrays before may be aware that it's really difficult to control the length of lines or extrusion in arrays. That's always failing. So we use nested family to circumvent that issue. Right, so oops. So I open my family that I've just created. I open that again, give that offset value, let's say a sensible value of 200, okay, go into my floor plan, reference level, and I just want to put in a kind of a grid of model lines that symbolize a grill, right? So just change my dimensions here to 500, and that's fine. So I'll create a model line here. I'll just place it place it on my base plane. That's important because I want to have that moving up and down as well. Place it here. Then I'll start and array that. So select it, array it. Say second or last. Now I want to align it with this one as the last one. Say 5 to start with. So that's a simple array. Now I want to align and lock the ends of the array elements here and there. But yeah, that doesn't work. So I can't really control the length by that Y parameter. So no matter what you try, you may say, all right, I create that line and put in the parameter straight to those line ends or something like that. Trust me, you will fail. Right? So therefore, another workaround for that will be to nest a generic component family into your host family. So we say new family metric generic model. I won't make a line-based family, I just make a metric generic model family. Say open. Could create a face-based family, it wouldn't really matter too much. So create a couple of reference planes. One is actually enough, sorry for that. Now create my model line. So I create it on the side here to make sure that I use the align tool and align and lock properly. There we go. Now I dimension it and make it a parameter. This is my length. It's an instance parameter as well. Right, now I save that family, but I just load it into my offset 01 family, right? And while I'm here, I just place it down here. Now I align that, oops, oh I can't, there we go. Now select that family. Oh yes, it's the wrong way around, so I need to actually align it up here. And now I select that family, and instead of locking it down the bottom here, I just define the length parameter as that was my Y parameter, right? So therefore it's always going to be that same length. And I can now create an array. Say last from here to there, let's say 3 elements. Now align again this one to the sorry, I just need to align this one to that one and this one to that one. Lock it, and then I need to say 800 here. You see that they are screwing up. Last step is you need to align the last, where's my last? One there. So align the 2 of the ends, or 1 of the ends of the first and the last one, and that should always keep them in line. So let's make this 200, and let's flex it again. So let's just go practice testing your family once in a while. HR to reveal all the elements again. And this is our array. Now that we've created that array, we want to make that array parametric. So we add a parameter called number. Make that an instance parameter as well. Say OK. Now we can control that number. 5. Apply. All right, now that we have created that number, we also, and we are getting to our second array topic. So that was chaos prevention by nesting families and aligning them properly in your family, right? We use nested families. Second one is foolproofing. So now I want to make sure that I can control the offset between those grid lines, right? And the problem that occurs is if I've got a very small grill, the offset may make the formula only creating 1 line, but an array always has to have at least 2 lines. So I want to have an offset between these ones, let's say of 100 mils, right? So therefore I just create a parameter, call it offset grid, grid offset. Grid offset, say an instance parameter, it's going to be a length parameter, and that's fine. Grid offset, and now the number of my array is going to be x divided by grid offset. So grid offset 100 is going to be x divided by grid offset. Therefore, this will give me 8 grid lines. So this is obviously then a rounded value. So therefore, it's not necessarily exactly 100, maybe a little bit more or a little bit less, but plus minus 50. Now, if I change that offset to be, let's say, 300, I only get 3 lines, right? And if I go further down and make parameter x even smaller, let's say 500, I get 2 lines, which is still working, but now when I go to, let's say, 300, I only get 1. When I say apply, it tells me parameter number has an invalid value. As discussed before, we only have 1 left, but arrays must have at least 2. To circumvent that, we need to put in a formula here. So we need to say if, in brackets, that x divided by grid offset is, I'll just expand that a little bit, if this one here is smaller than 2, then make it 2. Otherwise, make it exactly what it is. Oops. Otherwise, make it exactly what it is, right? So if this gives me a value smaller than 2, then make it 2, so that we always have at least 2 elements here to make it foolproof. So if I change that to be 100 now, oops, that was the wrong one, so let's make this one 200, it's always going to be 2 or more. So if I change x to, let's say, 1000, it's going to be 3, grid offset 100, and I'm back to normal. So this is how to foolproof your array so that it's not going to explode when you've got a very small element that will only give you one line left over. Right. The next one, next topic that I want to cover is a one-member array. This is going to be a little bit more complex. However, if you know how to create those formulas here, then it's no rocket science. So going back to our Revit model, first of all, I need to have this parameter set as it is, right? So this is my actual number. Now I say I add a parameter and I call it array. Right? This is going to be a yes/no parameter. Group it under other so that I've got them all together here. It's going to be instance parameter. And now I also create an additional parameter, say add, and say single. Right? So these are yes/no parameters that allow me to turn on the array or turn on a single line. Right? So make this an instance parameter as well. And say OK. Turn them both off for now. So now I open a group, one of the group members, doesn't matter which one, right? Edit group, select that family here, that nested family, and under visible here, I assign the parameter which I called array, right? Therefore, finish. Those lines should only be visible when the tick box array is ticked, right? So when do we want to have this tick box array ticked? We want to have that ticked if x divided by grid offset is larger 1, right? So as soon as it's 2 or more, then please show me the array. And if x divided by grid offset is smaller 2, please show me the single line. So we don't have a family placed yet to display when single is turned on. Therefore, I just create the family, or I place that family again. And just move it in here. Place it anywhere like that. Make sure I align it to this one. Select it. Assign the length parameter to that was y. And now I align it to the center line here. Right? Finish. Now select it and assign the visible parameter, visible tick box to single. Say OK. Now I load that family back into my project, say into family webinar sample project. I'll write the existing version and parameters. As we can see, we've got our grids here already. I must have not placed them on the proper reference plane, but it doesn't matter for now. It's just to show you what it means. So you see that at the moment we've got 8 elements or 8 lines. They're all displaying because the tick box is set to array. When I say grid offset, let's say 500, I only have 2 left. Oh, I must have made a mistake with the formula for single, because now with 2 elements, single and array are turned on. Right? So I go back into the family, check this one, single, visible, when this is single, and in here, number, let's check this one, 500 and X 500. Alright, that seems to be working well. Edit group. Visible when the array is turned on. Can't see where the issue is. I'll load that into the project again. I'll write the existing version. And I'll now check what happens. Grid offset, X 500. Therefore, when I've got only 1, then single is popping up. When I've got more than 1, the array is showing up, right? So like this 1200 and the grid offset 100. There we go. Array is showing up. So this way you can foolproof your family, as well as making it possible to create an array with only 1 member. It is not the array that's showing 1 member, but it's a good workaround. So let's go to the next next tip. Position and orient MEP connectors anywhere in a family. So yeah, just to give you a heads up, connectors can't be turned on or off via parameters and families, just like we did with those lines a few seconds ago. That's not possible. Well, to place them in different locations with the correct orientation, they need to be rotated and positioned by parameters. That's pretty complex, and that's the most complex family we are editing now. So a reference line is a key to achieve this reliably. I'll just show you the concept, and I'll make sure that I'll provide you with a finished family to download at some stage. So just to quickly show you, can you see we've got connectors in this unit here, and we are able to actually move those connectors around, right? So we've got tick boxes to move them to different locations. Also, I can move them to the right side, right? So it's pretty complex geometry in the background. Another option may be a plenum box like that. So you may want to turn that connector for the duct outlet, want to have that in a different position, right? So those are the areas where you may want to try and use this tip. Okay, I'll just create a quick new family, metric generic model. There we go, and we'll create a face base as well. Okay, so to start with, I just create a couple of reference planes here. As always, we need those reference planes necessarily. So this is Y, and this is X. So I'll just select this one, label Y. It's an instance parameter. This is X. instance. So yeah, not some people say width and height, but it's not really width and height. It's length and width, or width and length. So I call it x and y, and the z values are called z, right? The height, quite often. All right. So the key for success for this one is to create a reference line that I'm able to rotate any angle I like and to position in anywhere I like, right? So I'll just show you the workflow. If you don't do it that way, I have not been successful doing it any other way. So I just create one reference plane more in here, right, like this. And now I create a reference line, right? So, and I create that line just somewhere here. I'll now give that reference line a length. You don't need to give it a length necessarily, but then it might change its length during when you edit other parameters. So I would do it that way, add parameter, so ref line, or I call it spigot, sorry, spigot length, make an instance parameter as well. Right, we now need to make sure that we create a few dimensions, right? So first dimension that we create is this one here. That's the, I call it EY for eccentricity in direction Y. Okay. EY. Instance parameter. So, okay. Next one is I now have to dimension not the reference line but the dot at the bottom here. This is going to be my EX. Right? And that's one of the keys. Don't dimension the line, dimension the dot down the bottom. Add parameter, EX, instance. Okay. All right, now I lock and align the reference line to my reference plane here to control EY. Lock it. Now I place an angular dimension from this reference plane to this reference line. So this is going to swap around a bit. So yeah, you can't really control where it ends up, right? So just to test this setup, so I just select I select the line and change this to be, let's say, 135. So that's working well. So my reference line is already moving around, or rotating around, sorry. If I change this to be 300, this is going to move as well. EX, that's the third one. If this is working, I'm pretty confident that we've done everything right. So 400. Make this 200. Again, be aware that you can't type in a minus 200. If you would want to do that, refer to my first tip. So that would enable you to make a negative value in here. So, all right, but that seems to be working. So I just want to check one other thing. I type in 270. What is happening now is that Revit is mirroring the dimension. So I don't want that. And if I make this dimension a parameter, so angle, instance parameter as well, if I do that and type in a new value, 270, it remains where it's supposed to stay, right? So I can type in any angle, right? And my reference line is just rotating, orbiting, and positioning itself wherever it needs to be. So 135, for example. There we go. All right. Next step would be now to make sure that the reference plane is located in a proper Z direction, and that I position a parameter at the end of them, right? And I also need a box for my geometry of my model. But I'll skip that. I've got a sample family that I'll provide you with. So have a look at the 3D view. Sometimes those dimensions here pop up, so visibility graphics overrides, show annotation categories in this view, turn it off. Okay. I also want to turn off my dummy geometry here. That's my face where I place the family on, HH. Oh, I have obviously turned my reference line off as well, so only dimensions, turn it off. Right, now I need to place a connector, and the good thing with connectors is that I place a duct connector in this case. I can place it on a face, or I can place it on a work plane, right? And now I can pick a plane, say OK. Pick a plane, say OK. I'm experiencing some little issues here, but all right. Duct connector, work plane, pick a plane. There we go. I can now, when I hover over, oops, 1 second, create duct connector, I say work plane, pick a plane, say OK. Oh, I'm experiencing some little issues here. You may be able to see it on your screen. Just got to check one thing, sorry for that. Just opening this family here. Right, so, oops. Right, in here, when I go to my 3D view, there we go, just hide this one here temporarily. Right, can you see the reference plane when I select it? It's got the ends and so forth. I want to create a duct connector, work plane, pick a plane. Right, can pick any of the planes, the endpoints, or the other planes. But I'll see what's wrong here in my current family. So just go to my 3D view again. Oh, this was the wrong family. There we go. I may have turned off levels, reference planes. Okay, I think I've turned on the reference planes. That was it. Duct connector, work plane, pick a plane. Okay, now I can pick that plane, right? So now the connector is located in the end of my reference line. I can set the height and the width of that, or say it's going to be a round one. Diameter 200. Now in my plan view, oops. In my plan view, I can see that my connector is moving with everything I do here. So 270, connector is pointing downwards, right? And 135. Let's make that 45. And I can rotate and orbit it around. All right, just what I quickly want to show you. So this is the concept of how you can prepare that family. Now you just need to add geometry and make sure that the EY and EX parameters are always on your face, putting that original point here to the faces of your geometry. But that's pretty simple compared to that concept. But what I just want to show you is in that family, oops, sorry for that, again, I have created that family in a way that you can turn the parameters to the back, right? And they're just some fairly simple formulas that if back is turned on, then make EX a particular value, EY a particular value, and the angle a particular value, right? So this was our fifth tip, so I've got to hurry up a bit, otherwise I'm not in time. Sixth one is save in-place families and system families as component families. This method can be used for 2 or possibly more purposes. So make a custom in-place family available in your family library, or create a component family for categories which are not natively supported. So if you want to create a component family as a wall or floor, you can't do that by default in Revit. So, but there's a workaround. So I have created an in-place family here already. Can you see that's actually a roof, right? So that's a roof. It's an in-place family. So I can say model in place, edit in place model. Now I can edit that family, right? So I just show you that, oh, I've put in a parameter in, so I've put some effort in, I may have assigned materials, and now I want to make sure that everyone else can use that family in future projects. But I can't save this in place family as a component family. So every time I would want to use it, I need to find that project that it is currently in and then copy it across. So making a long story short, to do what I was promising you, so we can edit this in place family, select it, select the geometry. If you've got several geometries joined and maybe cut out of each other, select all of them, then make a group out of them, right? Call it, I don't know, roof cylinder or something like that, and say OK. So now before finishing that model, so we're still in this edit in place mode, I've got my model group here. While we're still in here, I scroll down in the project browser under groups model. I can right click on that group called roof cylinder and say save group. And this is going to save it as an RFA and not as a Revit project. So this is going to be a Revit family, which is great. So I just save that to into my webinar file here. Same as group name. Yeah, roof cylinder is fine. So save. It's opening it in. Oh no, it's not opening. So I'll open that file by Windows Explorer. So roof cylinder RFA is here, right? And I can now drag it into my project or just open it, and I can edit it in my family editor. So can you see that the category here is roofs? However, if I want to change that category, I won't find roofs. Okay, so when you create a family from scratch like a generic model and then want to change it to roof, that doesn't work. So the only way in creating a roof family is doing it that way. So now that I loaded into my project, so family webinar sample project, I can place it in here as often as I like. And the great thing about that is when I create a schedule, a roof schedule for example, that roof family here, oh sorry, I'm still in the so I cancel the model now. Yes, I want to discard them. Sorry for that. Now, so I was still in that in-place editing mode, and I've placed those families into the in-place family as nested families. So I didn't want to do that, but I should be able to find under roofs my roof family, which I just place. And I can place that roof family into my project, which is a roof, but it's a family, so it's not an in-place family. And the best thing is that when I open my schedules, roof schedule, I can even schedule them properly, right? So they give me a volume, an area, family name, and so forth, whatever I like to read out of it. All right, so this is our sixth tip. Again, I have to hurry a bit. Next one is going to be painting surfaces, so via parameters. Ever wanted to paint an element's face via parameter in a particular material without changing the main material? something like that. So that some of the surfaces are yellow, and that's done by a parameter. Very simple, but thanks to one of my colleagues, Chad, he pointed that out to me. I always, on the structural side, I always struggled to paint steel beams, for example, right? So the steel material had to be a particular material to communicate properly to analysis software and to be scheduled properly. And but I wanted to show them red or something like that. So we used view filters and so forth, but that's another great idea now. So when I just open that steel beam family, I say edit, I'm trying to modify and paint, right? Paint that family, but I can only create, use a particular material from my family. I can't use use a parameter to paint it. So let me quickly turn off the medium geometry here. So when I now create a parameter first, I add a parameter and call it paint, right? Can be called any way. Type of parameter, material, say OK. Paint, I want to paint it, I don't know, maybe earth, but change the color of earth to pink, so that jumps out. I also, I also want to make these, I want to rename that. Rename earth pink. So OK. Say OK again. And now, with that parameter in my family, I can now go in, first of all, I change that to shaded, right, and define. Now I paint it. And what I can now do is I can select my parameter that I've created. Can you see that I've got my paint parameter and bracket parameter and structural material parameter? Those are the two material parameters I can select from. So I select paint parameter, and then I paint the surfaces that I want to show pink. Right, so faces and so forth, probably all, but I just paint a few of those surfaces. Now I load that family back into my project. Overwrite the existing one. I can now control, first of all, the structural material of the parameter, right, which is steel, 250 MPa, but also how the surface is going to display. If I want to have that different one, render texture, then I can change it like that. So that's the 7th tip and trick. Trick number 8, power of 2.5D families. So yeah, quick and simple families for big tasks. So I'm using that on the structural side a lot, but I'm pretty sure that you'll find applications in the on the architectural side as well. So what we do is I'll create a dowel joint family, just a very quick one. So, oops, sorry, I create a new family, metric, generic model, line-based, so okay. In my plan view, I want to draw a line, and when I cut a section through it, I want to see a detail showing up, right? So create a model line, assign it to that reference line here, make sure that it's flexing properly, 2000, that's fine. Right now also, in my left view here, I want to plug in a detail component that is showing up as soon as I cut through that line in my project. So I'll do that by insert, load family. I've created a detail component already, so this is my detail. This is just a dowel joint detail. It's a very basic one. So annotate detail component. There we go. There's my dowel joint family. I rotate it so that I can place it up here. Place it here. Align and lock it to the center. So that dowel joint family has a few parameters like floor thickness. So I create a floor thickness parameter in my host family now. So I associate the parameter from the family to my host. So floor thickness, make it an instance parameter. Oops, sorry. I would also assign all the other parameters like dowel length, dowel diameter, and so forth now, right? But we don't have time, so therefore I say load into project, place it in my webinar sample project, place on face. Therefore I can just draw a line here, right? So hold down Shift key to make sure that it's 90-degree angle. Now I open my site view here, and this is my dowel joint family, right? Family 18. Create a section, and what pops up when I cut through that line is my dowel joint. I can now align and lock it to, oops, sorry. Oh, that's a type parameter now. Sorry, I should have created that as an instance parameter, and therefore I could have just dragged it up, aligned and lock it, and then it would even resize with the floor. Right, last tip and trick. We're running out of time. Convert ceiling-based families to face-based families. In my 3D view here, I have a Revit link, which I reload. So I've got a light fitting family, which when I try to place it anywhere in my project, it doesn't work. It only works on ceilings, which is a pain because sometimes you don't have the ceiling, but you still want to place your light fitting. Therefore, you create a dummy project with your light fitting in that you want to have face-based instead of ceiling-based. You link that in, then you use your collaborate, copy monitor, select link, so you want to copy monitor it from that link. In coordination settings, this is telling you which components you can actually copy monitor that can be ceiling based, right? Save, close. You copy monitor, oops, this element. So this is copying it out of the link into your own project, right? It may flip it upside down or something like that, but that doesn't matter. The only purpose we did that for was to create a family that is now, oops, I haven't finished that. So the only purpose for that was that I didn't want to have that ceiling based, it's face based now, right? So it's not a ceiling in the family, but when I create similar again, I can place it on any face I can see. So that's a pretty good trick. However, be aware that I was able to produce one corrupt family before doing that. So I would use it wherever you really need it. Otherwise, you need to recreate those families from scratch. All right, so last thing. So I hope you don't mind me going 5 minutes over the time. So set up thumbnail views. That's just a very little. That's just a little tip and trick. So when I open that beam family here again, you see that 3D view. There's only one 3D view. So whenever I save that family, I get a different thumbnail view, which doesn't look very nice in my Windows Explorer. So I just save this as family under webinars. Save it here. So that's the UB beam. When I look at it under webinars, zoom in a little bit. So this is what it looks like because my 3D view is currently orbited around like it is now. However, I should really duplicate the existing default 3D view, rename it, and I call it thumbnail. Then open that thumbnail view, orbit it around the way I like it so that all of my steel families or all of my beam families are orbited around the same way. Then I define, all right, detail level is fine. I want to have a realistic mode, for example, or shaded, whatever I like. Visibility graphics overrides. I can turn on or off model categories and annotation categories, so usually I don't want to see them. Then once I'm happy, I say save orientation and lock view, therefore I can't orbit it around anymore. Now the key is to say save as family under options here, I can say thumbnail preview should always be the 3D view thumbnail, right? Another little tip is compact file, right? So when you compact the file, you may get much smaller file sizes. Just show you, O2, save. In here, whenever I do anything in that family, right? So let's say I go back to my 3D view, orbit it around or change it to wireframe. Usually, or before I did that thumbnail view and assign the thumbnail to that, here my preview would have looked like that now, which is undesirable. Now, when I save the family again, save, the thumbnail view here is still referring to that thumbnail view. All right, so unfortunately, I don't have time to show you how to default a type when using type catalogs. So the key is to, I won't get into that, I'm sorry for that. I had two other topics I wanted to show you if we had enough time, but I was too slow. I have to work on that, sorry for that. Just as a quick summary, if you enjoyed the webinar or if you want to refer to that webinar in the future, you are able to download that webinar either from our webinar vault on our A2K website, so under events, webinar vault. There are lots of other, we've got 56 webinars on there, I think. Lots of other interesting webinars like from different texts from our team. Another option to keep up to date is our YouTube channel. This is not only showing webinars, or also other sources. Very interesting. Oops, what else did I want to say? Any comments or questions, please send your inquiries to either your personal A2K contact person or to marketing@a2ktoechnologies.com.au. So the recording I've just mentioned will take about a week to be uploaded, so you won't be able to access it straight away. Give it a week of time. And yeah, all right, so thanks very much for your time. I hope that you have enjoyed the webinar and that you will be able to use the tips and tricks to enhance your own family library in the future. Have a great afternoon and enjoy your weekend.